Okay, another day, another script. Let's take a look at volleyball, which really raises the question, which one of these files is the real volleyball? Jordan, would you like to guess?
I think it's circle.py.
Which one?
The for real one.
This one?
Yeah.
This looks promising, honestly. I'm not sure what this is, but I'm pretty sure.
It looks like it's stupid Python, stupid Pygame using a game engine for keyboard input.
Yeah, maybe. I'm pretty sure, though, the final version of the Volleybot, because obviously it went through a lot of iterations, and I'm not using version control, so all those iterations just live here as files and folders. I'm pretty sure the final version we used was T-Circle No Reset in the Mario Ballio for real analog way folder. Does that sound right?
Yeah, of course.
Oh, baby, there's a lot to take in here. This file is 255 lines. So, get your popcorn. Now, fortunately for us, a lot of it is just copied and pasted from the jump rope bot. We have a lot of the same inputs, NumPy, CV2, Pygame. Pygame is a game engine. We'll get back to that. Serial, time, and then threading. That's the new one. We'll get back to that as well. Anyway, right off the bat, we define a method called mean, which takes a list and returns the average. I stole this off Stack Overflow, if you can't guess. And it's just sitting here at the top. That's where methods go, right? You have methods, then variables, then more methods.
Yeah, of course. Yeah.
Yeah, no,
Very smart.
This code is not organized in any meaningful way. Then we have a good friend frame. Then we've got these variables, XP and YP. What do those stand for?
Experience points.
Uh-huh.
And, something else.
Yep, you're sure right. I guess we will figure out what these variables do as we go. Then we have B capital I. Can you guess what that one is?
Nope.
Cool. And then this is something I really love to do. I love to personify my variables. So we have our good friend, Mr. B, who is 0. But he's extremely 0, as you can see. And he's also a binary 0. None of this actually does anything, but obviously this guy's going to end up being a bit field of some point. So honestly, it kind of makes sense to initialize him like this. So you can look at the initialization and you're like, oh yeah, this guy's an integer. But really, he's a bit field. And then we have, is it over? Is it over?
Unfortunately, no.
I should really standard Python style is to use underscores. That's not an underscore. Underscores, I prefer camel case, but also you could just not capitalize anything. I sit over. So anyway, then we have these 3 functions here. Cap loop, do loop, and serial loop. What do you think these 3 functions do?
Well, one of them does.
Yeah, so the do loop does, as you can tell from the name. It is the loop in which you do. What does cap loop do? You'll notice the L is not capitalized. That's why it's called cap loop, because it's not capitalized.
Yeah, it checks out.
So what would you assume cap loop does?
Something involving Cappy.
That's a good guess. We're going to find out. And then the serial loop, I think, is pretty self-explanatory. That handles all the serial input and output. And we'll go through all these loops one by one. But then at the very end of the code, cheating a bit here, skipping ahead, all these threads are initialized. This is not helpful. So the thing about Python that I did not know when I wrote this is that it's single process. Everything runs in one process, which means it's all running on one core. And so my thought was, oh, by making it threaded, I can improve performance. That does not accomplish that goal. I mean, it makes some of this code simpler, because some of this stuff is, asynchronous in certain ways. But really what I wanted to do, what I intended to do here, what I should have done here, is to use the multiprocessing library, which lets you spawn multiple Python processes, which can then actually run on separate cores. But then you can't just, I'm pretty sure, you can't just share memory between them. You actually have to use message passing and all that fun stuff. And so that becomes complicated, and I've never messed with it. But that seems like what I should have done here. Anyway, all 3 of these threads are initialized and started. So all 3 of these methods, which are evidently loops, are going to be running in parallel. Or at least an approximation of parallel. So let's begin with cap loop. What would you expect to find in cap loop?
Caps.
Caps! The correct answer is global variables, because we're using shared memory.
Ah, smart.
Well, as long as you're not, writing to the same variable and doing, dangerous race conditioning stuff, it's not the worst thing, I don't think. Right? I mean...
Are you doing those things?
I don't think so. We'll find out. Anyway, we have frame as a global variable, and we have is it over as a global variable. And then all of this stuff is just straight up boilerplate copied and pasted from the jump rope bot, except now we print ret. I don't think we did that before, so that's fun. Then we have a big old try finally, and honestly this loop is not much. It's got a while loop with some more unnecessary parentheses, and then I stole this comment. I copied and pasted this comment. Then we cap.get several times. Why do you think I do that?
Lack of forethought.
That's a very good explanation. So if you recall, my issue with the Volleybot was that it had, or one of the many issues with the Volleybot is that it ended up with too much latency. So I was reading like, oh, how can you reduce the latency when you're using OpenCV and a camera? And it's like, oh, if you flush the queue by capturing a bunch, maybe that'll help. It didn't help. I should have deleted this code. I also should have put this code in a loop and not just duplicate it. But what's done is done, and now we're looking at it.
I don't think that's how code works.
Anyway, then we actually read it, and we save that to frame. Frame is, of course, a global variable that is going to be used by some other method. And then we check, is it over? If it is over, then we set, is it over to true? That makes sense. If it's true, then we set it to true.
What do you want me to say to that? You want me to call you stupid?
Yes, please.
Okay, you're stupid.
Thank you. And of course we break. I don't think you have to do this. I think there are other ways, but it's what I did. And of course, finally, even once this breaks, it'll execute the finally, and it prints no more caps. And it closes the cap, and then it leaves the loop. So that's the cap loop. The other simple one is the serial loop. So we can take a peek-see at the serial loop. It's got the global XP, the global YP, and the global Mr. B. Clearly these are going to be the X position, the Y position for the analog stick, and then the bit field for the buttons. Right? That makes sense.
Yep, probably.
Of course, the Volleybot itself doesn't use any of the buttons, but like when I'm setting up, I need to like get Cappy into position, and so I have this whole system where you can play the game using the keyboard, right? You saw that in the video, and that's probably here in the do loop somewhere. Anyway, we open the serial connection, we write a byte array. So if you'll recall, during my Volleybot video, I was very proud of the fact that I fit everything I needed in 1 byte, then eventually added analog support. So now what it does it just sends 3 bytes, one that's the X position, one that's the Y position, and then the bit field of the buttons, affectionately referred to as Mr. B. And then once the microcontroller has read that, it sends back a response saying, yep, good. And so this here will block and wait for that. And so that way we don't overflow the queue on the board because the board has teeny tiny memory. And then if it's over, it's over, and then we break. That's all the same stuff from before. So that's the serial loop. Pretty straightforward so far. The real fun is in the do loop, evidently. So let's go ahead and expand that. Do you like global variables?
Oh, I love them.
So we have global sir. Do you remember what sir is? It's global sir is undefined. Okay, so we don't have sir. If I had an ID, maybe I would have known that. Got the X position, Y position, Mr. B, BI. Still haven't figured out what BI is. Frame, and is it over? So what do you think of this?
Looks like you're trying to make a video game.
Yeah, so we import and then execute an entire game engine just for keyboard input. And this is one of the few lines of code that I actually showed in the video, and I got a nice friendly email from someone. I don't remember their name. I have it saved somewhere. Who was like, haha, you're an idiot. Right? He was a lot nicer than that, and he pointed me to some better ways to get keyboard input in Python. But I'm not stupid. I had a very good reason for using Pygame, and that's because Pygame also has very nice controller support. And at some point in this thing's life, it had controller support. And so I was justified, maybe, in using Pygame. It's not just for keyboard input. I'm not a dummy.
Haha, you're an idiot.
Oh. So anyway, we have going, which is false. Distinct from is it over, of course. We've got, what do you think these are? We've got the bixes, the x's, the b's, and the c's.
Well, it would appear that 2 of them are nothing.
Oh, yeah, why is... Oh, yeah. So anyway, these are probably ball x's, cappy x's, ball y's, and cappy y's. Because, you know, we had that smoothing applied to it. So we, like, keep this running list, and we just initialize it to 0. Which I guess we never used CYs, so. Then we have S-sums, which is 20 zeros. It's a cool trick if you don't know about that in Python. You can initialize an array of zeros like that. Then we have SI. And we had our BI before, wherever he is. There he is. I'm going to go ahead and spell the beans. I know what this stands for. It's index. So the SI is the index into S sums, and then BI is the index into these thingies.
Ah,
What would you call them?
I don't know that I would declare them up here.
That's fair. It's probably at the very
Maybe
least.
S index.
Yeah, something like S index at the very least. I don't remember what S is. Oh, it's the score display, remember? Because I said I changed a lot of things, some of which helped, some of which might not have. One of those was applying smoothing to the score display. And so I think this is like the last 20 values. I don't know if that helped at all, but it sure added a lot of code, including this fun array. Or list, excuse me. It's not a NumPy array. It's a Python list. So yeah, I don't necessarily know what I would call this array. Yeah, I don't know. Anyway, probably anything's better than what I have. Then we've got a good friend prim, and then centering. Which I think that's pretty self-explanatory, right?
I guess that one makes sense.
Yeah. And then we have actually centering. What do you think the difference is?
I think the difference is centering is actually used in your code.
You know, that's a very good point. I could not tell you what actually centering did, if it ever did anything. Anyway, then we got now, which is now. And we have ftime, which is never used. And then we got a big old while loop, which is just the rest of the code. So all the rest of the code is going to get executed constantly. If frame is not none, we've got some redundant parentheses. Well, frame is a global, which is initialized to none. So this if does not get executed, and we're done. Of course, frame is in fact initialized here in the cap loop. So eventually, this if statement will get executed. And there's probably a race condition here somewhere. I never saw it. Maybe that's what the problem was, but I kind of doubt it. Right, because we just immediately get a copy of frame. You know, it's not like we're doing operations on frame while it's getting written to. It's just this one operation. And I don't know if this is atomic, but it's probably close enough. Maybe we'll get half a frame or something. Like maybe there'll be some tearing, but I don't think I ever noticed that. So I think there's actually no race conditions here, at least not important ones. So that's probably fine, right?
Congratulations. You hopefully aren't going to kill anyone with this code?
Yeah. What was the name of that thing? Yeah, this thing. If you want to read a horror story about bad programming, you should read up on this thing. Anyway, so we immediately get a copy of frame, so hopefully there's no weird race condition-y stuff here. We increment BI and, mod it by 5, so it goes like 1, 2, 3, 4, 0, 1, 2, 3, 4, 0. It's just indexing into this thing, like I said before. We have this array called pressed, and so I think this might just be used for the keyboard stuff, but that's just an empty list. We crop out the score display. We apply the transformations that we did from the jump rope bot. We increment SI. And then we do some slightly weird stuff here, where we take the average of this. If it's less than 20, we add it to the thing. Otherwise, we append. So basically, we just have a rolling list of the last 20 sums of values in the score display, and then we average them, which makes sense. Like, I don't think this actually helped anything, but, it was worth a shot. So then we got this fun if statement. If prim is not none, comparison with none performed with equality operators. What? What do you want me to do? Oh. Yeah, that makes sense. And centering equals false. And going. Okay. So prim is none.
Is not none.
No, prim is none.
Oh.
So this if does not get executed.
Then
But then prim becomes a copy of S. S is the score display. And we have this if statement. If time.time minus now is greater than 1.3. So if now minus now is less than 1.3. Let's just look at this if statement, because otherwise none of the rest of this code is going to make any sense. So diffo, our good friend diffo is back. I do some nonsense here. Oh, you're going to like this, Jordan. Remember before when I divided by 1,000? Because I didn't like big numbers?
Uh-huh.
So now we multiply by 1,000.
Because you like big numbers.
Yeah. It's completely arbitrary. This does nothing. Also, I'm not really sure what I'm doing here. I'm like subtracting or taking the absolute value of the subtraction of the average. I think that makes sense. Like, I think that's still a valid way to say, has this thing changed by some certain amount? And this is the average of the first half minus the average of the second half. And because it's like a rolling thing, that'll be, however many milliseconds ago versus the last few milliseconds. That I think this makes sense, but it also meant I had to just retweak this number, because that was the big part of getting the jump rope bot, was finding this magic number. But now, because I'm using this different method, it's a different magic number, and so I had to go through all this again. So anyway, if diffo is above this magic number, we print the bell, so it dings at us, just like the Volleybot. Then we set centering to false. Centering is already false, and it's always false. That's because this is T-circle with no reset, you see. This is the version where Cappy never resets. So I think the only difference between this and the normal version is just setting centering to true. That's definitely worth creating an entire new file, right?
Of course.
Anyway, then we reset now, which is part of the cooldown thing. So right, we'll get there later. Oh, and if diffo times 5 is greater than 600, then we print wow, so big. Right, so like I said, I had to, redo all the jiggering to find this magic number. And so I wanted to make sure, it's not getting too big or something. I don't remember.
And then you had to do some rejiggering to find that other magic number that you can, say, wow, so big, too.
Yeah, and it also dings it, yeah.
Mm-hmm.
Alright, yeah. This was a mistake, messing with the score display detection. But, obviously there was some problem with it because it accidentally triggered that one time. I don't really know what happened there. Anyway, then we make a copy of S, and, that's how this stuff works. You saw that in the jump rope code. And then basically, this is just a cooldown. Because, we set now to time.time. That is not a good variable name. Because, when you assign it, time.time returns the time at now. And so you assign that to now. But then a second from now, that's not going to be now anymore. Now isn't going to be now. So then down here, you have time.time minus now. And time.time is now. But then now isn't now. And it's this code does not read like well-written prose.
No, it reads like the ramblings of a madman, which sounds pretty accurate considering what this is, so.
That's fair. But anyway, basically, 1.3 seconds after this if statement executes, this if statement executes. Remember, this is all in a loop, so, it's passing by many times. And, so, here we set centering to true, and so centering isn't false, which means this loop, or this if will not get executed. It will only get executed once, but then after 1.3 seconds, once we come around the loop again, this if statement will be executed, and we'll reset centering to false. So then here's just a bunch of numbers and stuff. Oh, right, yeah, oh. I showed this code once on a live stream, if anyone has not seen that, and I got so much shit for this line. So we'd use cv2.split frame 2, and that splits it into the red, green, and blue. And we unpack that tuple into these 3 variable names, blue, G, and R. Why do you think I named them like that?
Because you hate yourself or anybody who tries to read this code.
That's a very good explanation. Because see, the thing is, we don't use blue, right? We don't care about the blue channel, but we do use green and red. So I gave green and red nice short names because I use them. But then the variable that I don't use, I gave a long descriptive name. So that's the exact opposite of what a sane person should do. Again, this is a dummy unused variable. It should be an underscore. And then, if I want to use nice short names, sure. I think people know what G and R mean in this context of colors. But, God, giving the variable that I don't use the most descriptive name, I have no idea what I was thinking there. But now we have to live with that decision. We all have to live with that. So anyway, I draw some rectangles onto the screen. You probably saw those if you watched the video. Those are just those nice little rectangles that help me align the thing and see where the thing is. You don't really need to understand this code. It's all just boilerplate. But then we blur the red channel and also crop it at the same time in the same line, which is maybe not super clear that we're doing 2 things at once here. But, and also just everything here is just a magic number. Some of which are identical, right? It's not like they're all unique numbers. I am actually reusing numbers here. And some of them are computed from others. This is obviously this plus 80. So this is all bad. These should all be variables, and there should be math here. But no, there isn't.
He wasn't in a math type of mood.
Yeah. Well, I was doing all the math myself. When really I should have made Python do the math. It's like every time I wanted to change these numbers, you have to go in and change all of them. And like the ones that are computed from other numbers, you have to like go in. Yeah, that's bad. Don't do that. This, I have mixed feelings about doing two things in one line. Like, it's not really, well, whatever. We draw some more rectangles. And then, oh boy, this. So we call cv2.minmaxLock on red, which finds the minimum value, the maximum value, the location of the minimum value, and the location of the maximum value. And then returns all of that in one big giant tuple, which is fun that you can do that in Python. Then we have to unpack that tuple. We don't use this, we don't use this, and we don't use this.
What does the C stand for?
Cappy. All we care about is the minimum location, so like the least red part of the image, and that's Cappy. And we save that in CLock. All of these should be underscores, but honestly, since we're unpacking this many variables, we might as well just say CLock equals this index 2. That's probably maybe the best way to do this. Like, I have mixed feelings about this function that returns 4 variables, but like in a way it's kind of nice what I have here, like just leaving minval, maxval, maxlock, and you know what used to be minlock, so you can like at least see, oh, this is obviously meant to be minlock. That's not the best way to do that though. Really, it's not. But anyway, then that itself is of course a tuple because it's a location, so we unpack that location into CX and CY. So really what I should have done here probably is just say minlock, right? Minlock, index into that. So that removes any ambiguity. We know this is the min location. Or, you know, maybe give that a better name. And then we unpack minlock into cappy X and cappy Y. And, you know, we should probably give those better names too while we're at it. There, this code I feel slightly better about. How do you feel about this code?
Slightly better.
Yeah, it's still not great. These aren't pretty variable names.
A lot of stuff about this code isn't pretty.
But I could live with this more so than what I had before. And there's a bunch of commented out code. We can ignore that. CY equals CY minus 110. Why? This would be a good place for a comment, because I probably had a very good reason for doing this. Or maybe not even a comment. Maybe if I just had a constant. Maybe if instead of being a magic number, if this were a constant with a name that explained why I'm subtracting 110. But as it stands, I don't know why this is here. And so we have to live with that. This line evidently does something very important. Otherwise it wouldn't be here. But
judging by the rest of the code, that's not necessarily true.
You have a very good point there. But anyway, we draw a circle. We draw a circle where Cappy is. That's all just visual. All these rectangles and circles, they don't have any behavior. Those are just those nice debugging views that made that nice pretty video. Anyways, that's the red channel. We have found Cappy. Cappy has been discovered. It's honestly not that bad. A lot of this is just drawing rectangles. Basically, we just blur it. Right, I should explain what exactly we're doing here. So Cappy is the darkest part of the red channel, right? But we can't just find the darkest pixel, because, you know, there could be noise. It could just be some random pixel somewhere off in nowhere. So we apply this blur, which is basically just smoothing out the image. How do you pronounce this word?
Isn't it like Gaussian? Gaussian? I don't know.
I think it's Gaussian.
Gaussian.
It is.
That's
So
what I
you trust
thought.
me. I always said Gaussian. But I mean, it's named after a guy named Gauss, so.
It's okay. I had a math teacher who called it Euler's method.
Oh,
so,
that's fun.
You know, could be worse.
Anyway, we apply this Gaussian blur. There's like some other name for that too, right? Peter used it once when he was
Yeah.
trying to sound smart.
Yeah, I think so.
I think was it actually in the context of this? I think it might have
maybe.
been.
I don't know.
Anyway, there's some other word for that. It just smooths it out, you know? So if you have some random black pixel off in the middle of nowhere, that will just get blurred out and that won't count. Whereas Cappy is this big old blob of blackness. So then we find the minimum location, and that's Cappy. That's where Cappy lives. And then we basically do the exact same thing with the green channel, except now, of course, we're finding the ball. And we also have this fun little if statement. Oh, this is super fun. Look at this. It's an if statement but then it has this commented out part, and then within the commented out part is another commented out part.
Wow.
I mean, it's all just commented out. It doesn't do anything. So, like, it's not bad code, really. It's just ugly.
Very.
Again, if I was using version control, you could just delete that stuff and not have to think about it, because it's still there somewhere. But, you know, I'm afraid to lose it. Like, maybe I need these conditions somewhere. What? Oh, I'm, like, calculating the distance? Why was I calculating the distance? Oh, did I like not want him to get too close to the ball or something? Like, you can see this is like half of the distance formula here. And then I also had some cooldown of some sort. Interesting. Anyway, if we're centering, so, you know, we have that centering boolean. If we're centering, then we just ignore all of this. Like, really, this if statement should be bigger and include everything, because we're just like wasting cycles here, doing all these calculations we don't care about that we just throw out. Anyway, if it's centering, we just throw out everything we just did and set the block to this magic number, which is, you know, that spot off to the center left. And we set actually centering to true, which, as you'll recall, we never use this variable. Oh, wait, no. Oh, no, we do use it here. You know, we never use it before we reassign it, right? We initialize it. We initialize it up here somewhere, up here. But then we never use it until we get down here, and by then we've already reinitialized it. And so PyCharm was mad because I did that. But I don't think that's the worst thing in the world, especially because, you know, maybe it's a very Java thing to do, but like initializing a variable or like a JavaScript thing, you know, different languages have different scope rules. I guess Python is happy about me doing this, but So we're not smoothing Cappy's location, but we are smoothing the ball's location. I don't really know why. It just felt like the right thing to do. And so rather than just, you know, immediately using that, we save that into those lists from earlier with the B index that keeps incrementing. And then we find the average using that mean function from up there. Oh, and then we don't want to follow the ball off the left side of the screen, I guess is what this if statement's doing. So we clamp it to 40 at the minimum. And then we draw a circle. And so what that actually centering variable is doing, I think, is just changing the color of that circle for like one frame, I think. I think it was like one of the debugging things I added to see like when exactly this is triggering. I think that's what that is. That would make sense. Because like it's smooth, you know, it doesn't immediately just jump there. And so I think I added that so I could see instantly on what frame it was detecting the score display changing. I don't think it ever actually helped anything, but, you know, more redundant parentheses here. PyCharm is very upset about those. I turned off all the style guidelines because this used to just be completely littered with like, oh, you are violating this style guideline. You are violating every style guide in the book. But it's still mad about those parentheses. If going. Are we going?
Maybe.
Maybe.
Sure.
What is going? Oh, going equals not going. Going equals true. Going equals false. Going starts out as false. Evidently. Oh, you know what? I think it is. Okay, yeah. So there's a bunch of code we comment out here. Going. Anyway, going is eventually true. We'll get there. Going will eventually be true. We don't have to worry about that yet. So we have XP and YP. Oh, you know what? Those are the X position and Y position of the analog stick. But really here we're using them as vectors. So calling them position is weird, right?
Yeah.
Yeah. Anyway, this is about as simple as you can get. You just calculate the vector between the ball and Cappy, or Cappy and the ball, you know, whatever direction you want to think about it. And then we clamp it to 100 minus 100. Because, you know, the analog stick can only go so far. Well, it can actually go higher than this, right? Because it goes up to 255, I'm pretty sure. And so, but it's just we don't want Cappy to go too fast, I think, is why it's 100. And so really this should be a constant, right? Because I changed this number, but it's not. I'm proud of this comment. Put my hat back in the ring. And then we have a bunch of if statements that are like, oh, if Cappy is getting too far away, then, you know, stop him. Basically just set his velocity. This should be like velocity or something to 0. And that's in all 4 directions. But then, but for real, these are like, if he's still going, if he's gotten like really far, like even farther than this, then we actually move him in the opposite direction. And they, you know, I don't know how many of these ever actually got triggered, But, you know, I mean, I'm sure these did many times. I don't know if these ever actually did anything. But, you know, I had that problem, as you'll recall from the video, where Cappy would just fly off the screen and then never come back. Because he's really bouncy, right? And then we have commented out versions of everything we just saw. Then there's more commented out code. I love the commented out code, so you can just skip past it. It's great.
Yeah, it's really, you know, just put a bunch of commented out code everywhere, and then you get to scroll so fast because none of your code matters.
Yeah, it's wonderful. So anyway, that's most of the logic. Then we've got this Pygame stuff. This is just boilerplate Pygame. I think if you don't have pygame.event.get, if you don't call that every frame, it'll just like lock up. Or no, I think you have to iterate over it, otherwise it'll get mad at you. Yeah, because I think this is like a queue, and like a queue gets full or something like that. I don't really know the internals. But if you don't have this, everything stops working. And so we just, I think if you press I, oh wait, no, oh right, this is if you close the window. If you close the window, it'll close the program. That's what this does. More redundant parentheses, my favorite. But anyway, we use Pygame for keyboard input, of course. And so basically this just, I guess, returns a list of keys that are pressed. And then we translate those keys, which I guess Pygame gives you a list of like key codes, which are like integers or something. And we translate those into actual like strings, like A or space, things like that. And we put those in this pressed list. So that's what this does. And so I'm pretty sure if we look at this commented out code, yeah, originally, before we had analog control, we just put our, I'm saying we, you had nothing to do with this, right?
I sure hope not.
Yeah. I just put the strings W, A, S, and D into this pressed array, and that's how I got Cappy to move, which worked, I guess, kind of, technically. But anyway, yeah, this is how we get keyboard input, and so you can move Cappy around using W, A, S, and D, and like, you have a few extra buttons as well, which then proved to be useful in the next one, the YouTube plays script. And that's also where going comes in, because, you know, first I have to get Cappy into position, and then I hit the G key, and that sets going to true, and that makes the goey actually go. Here's Mr. B, our good friend Mr. B again. He's set to 0 every iteration of the loop, and he's a bit field, so, you know, you OR him with numbers that look like this, and so that just sets this bit to 1, that sets this bit to 1, and so all of these are, you'll notice, ifs and not else ifs, except for the ones that are else ifs. And so that way, so like, if space is pressed, then we set this bit to 1. If Z is pressed, we set this bit to 1. Maybe there's some like slightly nicer way to write this, but honestly, this is just like whatever. Now what's going on here? Right. So if we press W, it's like if we're using the keyboard, then we set YP to, you know, negative whatever. Otherwise, we need to reset it to 0, right? Because otherwise it'll just keep going left. But if we're going, right, if the script is running, if like the bot part of the script is running, we don't want to do that. And so we do that here. Why don't we do it here? Why don't we do it here?
It's a good question.
That's a very good question. Maybe this would be a good place for a comment to explain what the hell's going on here. But we do it here, but then we don't do it here. We don't do it for S and D, which are down and right. Why? I'm not sure. Maybe I had a very good reason, but it's also entirely possible that I didn't. Which is more likely.
I'm gonna go with the latter.
Yeah. Anyway, then there's that boilerplate again, because, you know, we have a Pygame window, but then we also have OpenCV windows. And so if either of those are closed, or if you hit the Q key on a OpenCV window, whatever, then we close. We print a bunch of debugging information. We draw a line with an arrow at its tip. OpenCV gives you so many fun methods. And that's, you know, the arrow that shows the direction Cappy's moving. We actually show all that stuff, and then we reset Ftime, which is never used. Ftime is never used. And that, my friends, is Volleybot. It's a hell of a lot more complicated than Jump Rope Bot, and probably poorly written. That's not a word.
Yeah, well, you know, you have 5 times the codes. That's 5 times the opportunities to make bad choices.
Yeah. Honestly, though, the actual logic of it's not that complicated. There's just a lot going on here. The end.